Here I'm assuming you have been through the basics of what even, odd, and neither mean when applied to function symmetry. We're going to go through three examples that are a little more complicated than basic polynomials. So we have here several functions. We have cubed functions, we have squared functions, we have square root functions, and we have absolute value functions. We're going to see how you determine the even oddness of all of these. So in the first example, I've got the square root. I'm writing right here, and I'm going to say, what if we take the negative x input of this thing? Well, look what happens. We get 6 times negative x squared minus 4. Now, what happens when you square a negative? Well, for that, we just get a positive x squared. So this was very quick. You see it's exactly the same as the original one. You can compare it right there. This is therefore an even function. Okay. Again, it all comes down to this test. F of negative x. What's it equal? Does it equal the original function or the opposite of the original function? Let's try it again down here. I have f of x equals this big complicated thing, and I'm going to stick negative x into it. Well, watch what happens. We get 6 times negative x cubed plus 3 times negative x. And then the whole thing is cubed. So we'll work through this one step at a time. Dealing with the innermost parentheses first. I have negative 6x cubed minus 3x. And then I cube that whole thing. Now, honestly, this would be really complicated. So instead, I'm going to use a little algebra trick right here and factor out a negative 1. The negative 1 factors out. I have to cube the negative 1. And what's left behind is 6x cubed plus 3x, still cubed itself. So take a moment to convince yourself of that step I did right there. I factored out a negative 1 cubed. And then when I keep going with this algebra, what I get is negative 6x cubed plus 3x all cubed, which is exactly the opposite of that original one. So this guy is odd right here. And for the last example, what I want to do is an absolute value function. I'm going to plug in negative x. That's our basic test. And look what we get. 5 times negative x minus 3. Okay, well that's just the absolute value of negative 5x minus 3. Oops, not a parentheses. That's an absolute value symbol. Okay, and now I'm going to say that this is not even and it's not odd. Because if you compare it to the original, you see it's not exactly the same. There's that negative 5 instead of a positive 5. But it's not exactly opposite because the negative 3 is still a negative 3. So this guy is neither. Now, if you're wondering, okay, well, that's great. How do I know if it's exactly the same or opposite or not quite either? Well, what you can always do, if you're not feeling so confident on the algebra part of it, what you can always do is just plug in a number. Okay, I'm going to say, watch this. F of 1 equals the absolute value of 5 times 1, that's 5, minus 3, equals the absolute value of 2, which is just 2. But what if I had done f of negative 1? Well, then I would get the absolute value of negative 5 minus 3. So that's the absolute value of negative 8, and that's 8. And see, those aren't the same, and they're not opposite, so that it proves it's neither. I should be careful about that word proof. It doesn't prove that it's neither. It demonstrates that it's neither for 1 and negative 1. But if you are talking about proofs of symmetry, you have to be very careful with this right here. This does not constitute a proof. These things are proofs, okay, when they use x, not a number. But using a number is, in all practical terms, very, very nice, and sometimes it simplifies the algebra. Now, I want to give you some basic rules for all these things. Remember I said there's 4 types of functions, and I've got them written out right here. You've got your squared function, your cubed function, your absolute value function, and your square root function. And you can see I gave you some basic guidelines for what happens if you square an even function, or if you square an odd function, or if you cube a neither function. So screenshot this, write this down in your notebook, whatever. It's some useful shortcuts. I don't necessarily believe that you have to memorize these for the rest of your life. The f of negative x is the best test of all the very tests we did at the very beginning. But if you're in a unit that's intensive on this stuff with symmetry, this is a nice cheat sheet to have in your notes.